Hello everyone. Good evening. Good evening to all of you. Am I audible and visible? I'll launch a poll. Just give me your answer, okay? In the poll. I have launched a poll. You guys can give your answer. Just tell me if I am visible and audible. Good evening, Priyanka. Good evening. Yes. Good evening, Pallavi. Very good evening. Okay. So I'm audible and visible to all of you, right? Fine. Yeah. Good evening, Sneha. So let's start. Let's start with our chemical kinetics. So in the previous class, what we have discussed? We have discussed the integrated rate equations and the half-life formulas for first order and zero order reactions, right? So let me recall. Today I'm not going to give you guys a recall test, but let me recall the concepts with the formulas. Okay, for zero order reaction, the integrated rate equation was concentration of R is equal to concentration of R naught minus K into T. And the half-life for zero order reaction is T half is equal to R naught divided by 2K. Okay, so these two are the formulas from zero order. One first is the integrated rate equation formula. Second is the half-life formula. Okay, and coming to the first order, I mean integrated rate equation, T is equal to 2.303 by K into log of R naught by R, and for half-life it is equal to 0.693 divided by K. Okay, so these are the four important formulas which you should study. I think you have studied on that day itself. Did you guys study and memorized all the four formulas and all the graphs which we have learnt in the previous class? Are you all thorough with those things? Say yes or no, students. Have you guys studied all the four formulas and the graphs which I have discussed with you guys in the previous section? Yeah. Yes. Okay. Okay. Very good. Very good. So now, from the concepts which we have studied in the previous class, that is from this integrated rate equation and half-life concept, I have taken the previous year question. Two previous year's questions I have taken. Okay. So let us solve those questions first and then we will move on to the remaining, to the new chapter for today. Okay. So today, the first thing itself is solving this previous year question. So can you guys solve this question and let me know the answer in the chat box? So the question says that if the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by rate constant is K, what is T? Which option is correct? Sivamani is saying option D is the correct answer. Okay, what about others? What about others? What do others say? So let's give some time for others, okay? Srujana is saying option C. So which is the correct answer? So let's wait for others for some time. Then we will discuss. So three of you are going for option C. Okay. Keep giving your answers in the chat box. I will see. I will see. I will check. At the end, I will check. After 30 seconds, I will solve this question. Okay. And at that time, we will check which is correct. Sneha is going for 4. Let's see. Lingana Gauda MH is going for option C. Okay. What about others? What about others? I'm waiting for your reply. Everybody is getting option C or D as the answer. Either one should be the answer. What about others? I'm waiting for others' replies. So we have 55 participants today and I'm waiting for your reply. C. Okay. C. Yeah. Madhukar Reddy is going for A. Okay. So let us discuss. Rate constant for a first order reaction is K, the time required for the completion of 99%. Means initially, the initial concentration of the reaction would be 100%. So after some time T, the concentration of the reactant or the reacted amount is how much? 100 minus 99 because that is 99% of the reaction got completed, got over. So now completion of 99%. So from the 100%, 99% has got reacted with each other. The remaining will be 100 minus 99. Okay. So now we have to find out the time required for this 99% completion. So which formula we have to use? So the question says that it is a first order reaction. So from the first order reaction, T is equal to 2.303 divided by K into log of R naught minus R. Right? So just substitute. K rate constant is taken as K only. So just keep as it is 2.3 divided 303 divided by K into log of R naught is 100 and RT is 100 minus 99 which is actually equal to 1. Okay. So here we have log 100. 100 can be written as 10 to the power 2. So yesterday I gave you one formula, right? What is log of m to the power n? It is n into log m. Okay. So we have log of 10 to the power 2 which is equal to 2 into log 10. And log 10 value is how much? Did you guys study the values of log? Some logs values I have given you yesterday, right? Yeah, very good. Log 10 is equal to 1. So 1 into 2 is 2. So the answer for this entire term is going to be 2. Okay. So log 1 will be 0. Log 1 will be 0. So we will not consider that. So the answer for this entire term is 2. Now T is equal to 2.303 divided by K into 2. So 2 into 2.303 is how much? 4.606 divided by K. In which option this answer is given? Option A. Okay. Option A. T is equal to 4.606 divided by K is the correct answer. Why you guys all of a sudden have gone for option C and D? Only one person have said option A as the right answer. No? Who is that? Madhukar Reddy. Except Madhukar Reddy, all other students have gone for option C and D. Why? Not all, very few. Most of you have not answered. Hmm? So now all of you can able to understand, right? Why option A is the correct answer. Do any of you have any doubts? Everything is clear? Yes, right? Yes. I hope it is clear now to all of you. Please don't make the same mistake again, okay? So no problem if I'm making the mistake now. So don't repeat the mistake. All of us are learning only. Now we are in the learning process. We are learning through this question now. So now you have learned. You should not make the same mistake again. Got it? So shall I go for one more previous year question? Are you all ready to solve? That will be the last previous year question from the topic which we have discussed in the last class. Log log 100, how can you take log 100 as log 10, my dear? No, it is not the case. 100 can be written as 10 to the power 2. Okay. You cannot take it as log. It is a logarithmic function. No, so we have to follow the formula for logarithmic function. Is that clear, Vicky? Is it clear? Log 100 cannot be taken as log 10. Very good. Okay. So I'll go for the next question. You guys have to think well, think wisely, and then give me the correct answer. So don't just give your answer all of a sudden. This is the question. The graph, the given graph is a representation of kinetics of a reaction. So we have four options, and also we are provided with the graph. Y-axis and x-axis is given for zero order and first order reaction. You have to find out which option is correct. Observe the graph. Observe the graph. Think of the concepts which we have studied under zero order and first order. Then go for the correct answer. You can take how many? Yeah, 30 to 45 seconds to solve this question. That is more than enough. If you have learned the concepts thoroughly, then you can get the answer within 30 seconds. Just think of it and give me the answer in the chat box. I'm waiting for your reply. Soon, soon. Not even a single student has got the answer till now. What is this? Oh, Bhagat has got option C as the correct answer. Okay. So Nagashri also is getting option C. Sneha is getting B. JNB Kadag also C. Kokrajag students are going for option C. Okay. What about others? Give your answers. Give your answers soon in the chat box. Give your answers fast. Okay. Fine. So let us go for the discussion. So many of you have given option C as the correct answer. Yeah. Before moving on to the explanation, let me go for the answer. Option C is the correct answer for this question. Okay. Because for zero order reaction, here y-axis is taken as rate and x-axis is taken as concentration, right? So x is the concentration and y is the rate of the reaction. So what is the rate equation for zero order reaction? Rate is equal to, rate of the reaction is equal to K into, I'll take A. Okay, A as the reactant. A to the power N. And here this N is going to be 0 for zero order reaction. Okay, so anything to the power 0 will be equal to 1. So rate is equal to rate constant. Rate is equal to rate constant means the rate is not going to depend on the concentration. It is not going to depend on the concentration. Okay. So whatever might be the concentration, whether you increase or decrease, the rate is not going to get changed. That is the meaning. Okay. So that's why we are getting a graph like this. So here I'm increasing the concentration, but even if I increase the concentration, the rate remains same. So that is for zero order reaction. So the first half of the option is correct. Now coming to first order, here the story is between T half and concentration. T half means half-life, right? Let me erase this. T half is called as half-life. So half-life is taken in the y-axis and x is taken along the, concentration is taken along the x-axis. So yesterday we have studied the formula for half-life, right? So for first order reaction, T half is equal to 0.693 divided by K. So in this T half relation, we don't have the concentration term involved. So whatever might be the concentration, the T half is going to remain same. So we'll get a graph like this. Okay, whether you are increasing or decreasing the concentration, the T half is independent of the initial concentration or the concentration of the reactant for first order. Okay, so graph looks like this. So this graph is for the informations given in option C. So option C is the correct answer. Okay, so is it clear for all of you? Shall I go for the topic for today? Okay.
Yeah.
So today we are going to continue with the pseudo first order reaction. Okay, so in the integrated rate law topic, so the last topic is there. In the previous class, we have discussed the remaining things, the integrated rate equation and the half-life part. So one small topic is left in that. That is called as pseudo first order reaction. So can anyone tell me the definition of pseudo? What is meant by pseudo? False. Very good. Pseudo means false. So what is meant by pseudo first order reaction? It is not a first order reaction. It is not called to be a first order reaction, but it is a first order reaction. Am I confusing? It is not called to be a first order, but it is a first order. I'll give you the definition, okay? Don't worry. The type of reaction which obeys the first order rate law, although it has higher molecularity for the reaction. What is meant by higher molecularity? We may have more than one molecule. We may have two molecules, we may have three molecules, etc. But whatever might be the number of molecule, whatever might be the molecularity of the reaction, the rate, the order of the reaction is 1. So those reactions are called as pseudo first order reaction. Okay, so understand this better. I will take one equation. Okay, one reaction. CH3COOCH3. So this is an ester. This is an ester. Okay, methyl acetate is the name of this ester. And this ester is reacting with water to form acid. CH3COOH means it is a carboxylic acid and it is giving alcohol, methanol. So ester is reacting with water to give carboxylic acid and alcohol. Okay, so this reaction is called as esterification. This reaction is called as esterification or hydrolysis of ester. Or I can say this more clearly like hydrolysis of ester. Take this as hydrolysis of ester. Because the reverse reaction is called as esterification. Acid plus alcohol giving ester is called as esterification. So you can write this as hydrolysis of ester. Okay, we are hydrolyzing. Hydrolysis means addition of water. So now, if I write the rate of this reaction, since I have two reactants, the rate equation should be written like this only, no? Because I have two reactants, A and B. So both the reactants has to come here. Concentration of both the reactants has to be there in the rate equation. But this concentration, the water concentration is taken as K into K, H2O is taken as K dash. We are not going to consider the concentration of water. Why? Why we are not going to consider? Because that water will be present in very, very excess amount. The one which is present in very excess amount cannot determine the reaction order or the reaction rate. It cannot determine the rate of the reaction. So the excess amount of the reactant is neglected. So we are not going to consider that. And instead of taking this K into H2O, I am going to use K dash. So the equation, the rate equation will be equal to K dash into concentration of ester alone. Okay. So now this is the final equation. And in this equation or in this formula, I have the concentration of only the ester, not the water. So now what is the order of the reaction? It is 1. So actually we have two reactant, but in the final rate equation, we have the concentration of only one reactant. Okay, so that's why it is called as pseudo first order reaction. It is supposed to be a second order, but it is not a second order reaction. It is a first order. Okay, so one more example is also there. Acidic hydrolysis of sugar. Acidic hydrolysis of sugar is also an example for pseudo first order reaction. Okay, is it clear for all of you? Acidic hydrolysis means you can take a sugar molecule. Sugar molecule formula C12H22O11, and again you can hydrolyze this in presence of acid. Acid contains H plus, and this will lead C6H12O6 plus C6H12O6. So again here water is taken in excess. So
Yes.
yes, Neha. In most of the cases with water, this will be the case. But only these two reactions are given as an example under the pseudo first order reaction in your NCERT book. Okay, so try to memorize these two examples for now. In all the cases, whether we are taking ester or sugar with water, you will have this pseudo first order reaction only. In most of the cases. In most of the cases. There would be some exceptional cases also. Okay, so that is out of our syllabus only. Okay, clear? So this reaction is an example for acid hydrolysis of sugar. So this is the sugar molecule, sugar cane. Okay, when you hydrolyze it using an acid, you will get a glucose and fructose molecule. And this is also an example. Okay, hydrolysis of ester and acidic hydrolysis of sugar are the examples of pseudo first order reaction. Very important. Examples of pseudo first order reaction is very important. Okay, is it clear to all of you? So with this, we are wrapping up the integrated rate law topic, which is the third topic of this lesson. Now we can go on with the fourth topic, which is Arrhenius equation. Okay. So in this, we will learn what is Arrhenius equation and the mathematical interpretation of Arrhenius equation. So let's start with the equation. Arrhenius is the name of the scientist. Okay. So in this equation, we will have the mathematical relation between the rate constant and the temperature. So what is rate constant? It is denoted by the letter K and the temperature is denoted by the letter T. So we will have a relation between K and T in Arrhenius equation. Okay. So K is equal to A into e power minus EA by RT. This is that Arrhenius equation. Okay. So where K is the rate constant, A is called as Arrhenius factor or pre-exponential factor, and this R is the gas constant, which you know already, universal gas constant, and T is called as temperature. We have one more term EA, which is called as activation energy. Okay, you might be asking, ma'am, what is this E? What is the notation? What does this E denotes? Can anyone tell me the meaning of that E? Can anyone tell what does that E? Very good. It is an exponential function. So we have multiplication, we have addition, we have subtraction, and what else we have? We have logarithmic function and all, no? So likewise, this E is the exponential function. Okay, this is an exponential function. So K is equal to A into E to the power minus EA by RT is the Arrhenius equation. So all of you can take down this. K is equal to A into E to the power minus EA by RT is the formula. Now let us discuss. This is the mathematical expression, Sneha. Arrhenius scientist, no, he derived the relation. Okay, he has a derivation, and at the end he is relating this rate constant and temperature in his equation, and finally he is arriving at this equation. Okay, clear? This is called as Arrhenius equation. Now we will study about the activation energy in detail. So here is one reaction. H2 plus I2 giving Hi and Hi. Okay, so we have two reactants. One is hydrogen molecule and the other one is iodine molecule. These two are the reactants. When they both come closer to each other, they will interact with each other and they will form a complex which is called as activated complex. Okay, so here you can see a new bond is formed between the hydrogen and iodine, and the old bond which is already present there, it is getting trying to broken down. Okay, it is broken down one side and the new bond is formed. So bond breaking and bond formation is happening in the activated complex. Now after some time what happens? This bond, hydrogen-hydrogen bond and iodine-iodine bond will be completely broken down, and they will lead to the formation of HI. Okay, so they will lead to the formation of the product HI. And this is how we get two HI molecules in the product. Okay, clear? Now, what is this activation energy? We have a reactant, it is getting converted into a product through the activated complex pathway. Okay, so let me take a graph to explain this activation energy better. So I have a reaction coordinate in the x-axis and energy in the y-axis. Initially, I have H2 and I2 in the as a reactant. Okay, so this is the energy of the reactant. Okay, now after some time, those two molecules are going higher in energy, and the energy of the activated complex will be very, very high. Okay, because it is unstable, no? So the energy of the activated complex will be very high, and after some time, they give a product, which is 2HI. Okay, yeah. Srujana is giving me the definition. You see, very good, Srujana. It is correct. So this is the activated complex. The energy required, the minimum energy required by the reactant molecules to get activated. To get activated is called as activation energy. Okay. So the energy required to go from this particular state to this state is called as activation energy. Srujana, there is one small mistake in your definition. Okay. You have said no, molecules to be converted to product, not to product. The energy required to form the activated complex. To get activated is called as activated activation energy. Okay, so it should be little bit redefined in this way. The minimum energy which must be provided to a chemical system. Okay, chemical system with potential reactants to undergo the reaction. First of all, the energy is required to for the reaction to occur, and then only at last they form the product. Got it? Can you able to identify the small mistake that you have made? Definition is correct only, but little bit grammatical error is there. Okay. Yeah, got it. So the minimum energy which is provided to the reactant to undergo the reaction is called as activation energy. And here if you see, the energy of the reactant will be greater than the activation energy. Okay. So now we will go for the mathematical interpretation of this Arrhenius equation. So let me take the equation. Now if I take the logarithmic function on both the sides, what will happen? If I am taking log on both the side, I will have log k in the left hand side and I will have to apply log to this a. So I will get log a. And also if I apply log to this e power minus a by rt, what I will get? Log of e power minus ea by rt. So this exponential function and logarithmic function will get cancelled with each other, like plus and minus only. Okay. So they both will get cancelled each other. The remaining thing is minus ea by rt we have. So minus ea by rt is here. And this is actually, if I'm putting log here, then I have to use the number 2.303, right? So that is given here in the denominator. So this is the equation we are getting, or the formula we are getting after applying the logarithmic function to Arrhenius equation. Now, this equation is of the format y is equal to mx plus c, right? This is the y-axis, and this is m, and this is x, and this is c. So y-axis is log k, x-axis is 1 by t, okay? Relationship between rate constant and temperature. And minus EA by 2.303 into R, everything is M, slope, and log A is the intercept. Shall we draw a graph for this? You see here, log K is of y-axis and 1 by T, x-axis. So what about the slope? It is a negative or positive? Oh, I have written something. I have made a mistake, right? Yeah. Yeah. Slope is negative or positive, my dear students? Yeah, it is negative. So what kind of line I should get? I should get a line with negative slope. So a line looks like this. So it is cutting the y-axis at this point, and this is called as intercept, which is log A for this equation. Okay. Slope is minus EA by 2.303 into 1. So this is a mathematical interpretation of Arrhenius equation. This equation is again important for solving problems from this concept. Okay. So in one of the previous year question also we have this concept, this formula. Okay. So I will tell you, I will solve that question for you in the class. That time you will get to know. Okay. So just take down this formula and the graph. Shall I go for the next? Everything is clear till this, no? Shall I go for the next slide, students? Shall I go for the next slide? Yeah. Now I'm going to take the same formula and I have just rearranged. I have just took the log A, and which is there was on the right hand side, and I kept put it before. Okay, log A minus A by 2.303 into RT. So all of you can able to understand, right? I have took this log A and put it here. I took this and I have placed in front of this. Okay, so log A minus the entire thing will come. Okay, so this is the equation. Now at T1, at temperature T1, the rate constant will be K1. Okay, so now you substitute T1 in place of T and K1 in place of K. You will get one equation and it is taken as equation 1. Okay. At T2, rate constant will be K2. Now on substituting these two values, I will get equation 2. Now I have to subtract these two equations. Subtract equation 1 from equation 2. So how to subtract? K2, log K2 minus log K1. So this whole term minus the equation 1 term. Okay. So this is what we are getting. This is what we are getting. Now after subtracting the thing, we will get at the end, we will get log K2 by K1 because they are in the subtraction form, right? So it will go in the division for logarithmic function. So log K2 by K1 equal to the slope term and 1 by T1 minus 1 by T2. Now if I take the LCM, I will get a final relation with the T2 minus T1 by T1 into T2. So you don't have to worry about this derivation part. Just write down this last formula alone in your notebook and memorize that. That is enough. Okay. So if two different temperatures and two different rate constants are given to you, and if you are asked to find out the activation energy in your question, then you need to use this particular formula to solve the question. You should not go for the Arrhenius equation. Okay, so that will not help you. Only this equation, this formula will help you out. Got it? Clear for all? So what are the things we have discussed in Arrhenius equation topic? So we have studied K is equal to A into e to the power minus A by RT, and the terms is very important. Okay, the meaning of each and every letter is very important. So you have to study that also. And secondly, we have studied log K is equal to one equation. And also we have studied the relationship between rate constant at T2 given at T1. So these are the three formulas you have to study from this Arrhenius equation. Okay. So Arrhenius equation topic is also getting over here. Now from this topic, we will try to solve a previous year question. So this question is of assertion reason type. Can you guys go for it? Assertion says a reaction can have zero activation energy. Is assertion correct or wrong? Is it true or false? What do you guys say? Assertion is correct or wrong? Very good, Nagashri. Why it is false? Why it is false? Why it is false, students? Can you give me the reason? Why assertion is false? Very good, Sneha. A reaction cannot have zero activation energy. Yeah, there must be some energy difference between the reactant and the activated molecule. Okay. So the molecule, the reactant molecule should get activated to form the product. The reactant molecule should get activated to form the product. Okay, suddenly it will not go from reactant to product by having the same energy. So when it is getting activated, it takes some energy. So there will be some activation energy for all the reaction. A reaction cannot have zero activation energy. There will be some activation energy value. Okay. So assertion is false. Only in one option assertion is given as false, right? Which option it is? Yeah, option C is the correct answer. So, but let's check with the reason also. Okay, the minimum extra amount of energy absorbed by the reactant molecule so that their energy becomes equal to threshold value is called as activation. This threshold value is not a new term for you because you might have already heard of this threshold term in your class 11, which lesson? That atomic structure lesson. Okay, have you heard of this threshold energy term in atomic structure lesson of your class 11? Yeah, the minimum amount of energy required by the body. Yeah, it is the same thing. So this is actually the definition for activation energy. So reason is true, but assertion is wrong. Okay. So with this, we will close the Arrhenius topic also. Now the last topic of this lesson is collision theory and effect of catalyst. Collision theory and effect of catalyst. So first let's go with the collision theory for rate of the reaction. So in collision theory, before moving on to the theory, I would like to ask you one question. What is the meaning of collision? Collision or colliding with each other? What is the meaning of collision? Can anyone tell me the meaning of collision? Colliding, yeah, it is colliding with each other, striking with each other. Okay, collision means coming together and reacting with each other, colliding. Yeah, okay. So here in the collision theory, all the molecules are taken as hard spheres. Molecules are taken as hard spheres means you can imagine a cricket ball. Okay, so those things you can take. They are considered as a molecules are taken as a hard sphere. And in the collision theory, only the molecules which are undergoing effective collision is taken. There are two types of collision, okay? Effective collision and ineffective collision. Only the molecules which are taking effective collision can collide with each other and they can lead to the formation of new products. So effective collision is taken into account. For the effective collision to take place, the energy of the reactant should be greater than or equal to the activation energy. Energy of the reactant should be greater than or equal to the activation energy. And all the molecules, all the reactant molecules should have proper orientation. I will show you the proper orientation in the next slide. Okay, we will take one example and we will see what is meant by proper and improper orientation. Okay, if you guys want to note this down, you just note this down. By the way, I would like to launch a poll. Okay, I would like to launch a poll. In between, you can guys take down this. Why I could not launch? Okay, I'll just launch it after some time. I launched after some time. Okay, there is some issue. I'm not able to launch it. Okay, no problem. So for effective collision to happen, what are the things required? Energy of the reactant should be greater than or equal to activation energy and the molecule should be oriented in a proper manner. Okay. So with this, we will take a reaction as an example. The reaction is NO plus O3 giving NO2 and O2. NO plus O3 giving NO2 plus O2. So let me take these two reactants, NO and O3. So here is this blue color atom is nitrogen. Okay, this blue is nitrogen and the pink atoms are oxygen. So here I have O3 molecule and here I have NO molecule. Okay, so what do you think if the nitrogen, I mean the blue atom and the pink atom of O3 collide with each other, NO and O3? What will happen? Do you think they will collide in a proper manner or they will lead to the formation of product? They are not oriented properly. They are not oriented properly. So they will lead to NO and O3. No reaction has occurred. So we are left with the same reactants NO and O3. They are not going to strike with each other. But if I change the orientation, if I change the orientation means I'm going to keep N here and O here. Now in all these cases I have O. So now all the atoms are going to be same. All of them are oxygen. So one oxygen will collide with the other oxygen. One oxygen will collide with the other oxygen. And here also it leads to the same product. Product means NO and O3. Okay. Because the orientation is not same. So please mute yourself. Please mute yourself. Yeah. So students, what I was saying. So in both the case, NO and nitrogen and oxygen, as well as oxygen and oxygen, they cannot come in contact and collide with each other properly because the orientation is not same. So we are ending up with the same reactants NO and O3. Okay. But if I change the orientation, so here you see, I have changed. What I have changed? I have changed the NO. Before NO was like this and now it has been changed. The bottom part I have nitrogen and the top I have oxygen. Now here what happened? The oxygen of ozone, will come and try to collide with the nitrogen. Okay. And now the orientation is proper. Here you see the orientation is proper. They lead to the formation of NO2 and O2. And this is getting broken down and it leads to the formation of NO2 and O2. Okay, so this will come out. So we will get NO2 and O2. So only the proper orientation will lead to the formation of product according to collision theory. Okay. Now we will study the relation between rate and collision. Okay. Rate is directly proportional to the number of collision. Rate is directly proportional to the number of collision. Okay. Or collision frequency. Collision frequency is taken as ZAB. Okay. Yeah. Now the rate is directly proportional to the probability of effective collision also. So rate is proportional to the collision frequency Z as well as it is proportional to the effective collision. If the effective collision is more, then the reaction is more. And also it depends on one more factor, which is fraction of molecule with energy greater than or equal to EA. So rate is proportional to these three terms. So I can write one equation or one formula using these three relations, which is rate is equal to P into ZAB into E power minus EA by RT. Okay. Collision frequency means the number of collisions occurred per second for a given period of time. Okay, like how frequently the collision has occurred. Like if I take for 1 minute, how many collisions has occurred? The number of collisions is nothing but the collision frequency. Okay, clear Sneha? So this is the equation. This is the formula we are learning from the collision theory. Rate is equal to P into ZAB into EA, E power minus EA by RT, where P is the probability of effective collision and ZAB is the collision frequency. Got it? Now at last, we are going to study the effect of catalyst. So we have a reactant and that reactant is taking some amount of energy to get activated and leads to the formation of activated complex. Then at the end, it is forming the product. Okay. So this is the graph we have studied, right? So here we have the activated complex and this is the energy of activation for UC. What is meant by UC? Uncatalyzed reaction. If I am not using a catalyst, this will be the energy required for the reactant to get activated. Okay. Now, if I use the catalyst for a reaction, You see here, a new activated complex is forming at very low energy itself. So this is the activation energy for uncatalyzed reaction. This is the activation energy required for the catalyzed reaction. You see here, activation energy for the catalyzed reaction. So activation energy for catalyzed reaction is very less compared to uncatalyzed reaction. So what do you understand from this? If I'm using a catalyst, energy of activation is getting decreased. Means the reactant molecule is getting activated so easily or immediately by using the catalyst. So now what is the role of catalyst in a reaction? The role of catalyst is to alter the rate of the reaction. The role of catalyst is to alter the rate of a chemical reaction. Okay. How it is going to alter the rate? It is actually going to speed up the rate of the reaction by forming the activated complex immediately, easily. Okay. Without taking much time, activated complex will form soon and immediately, and it will be converted to product soon. So yeah, without catalyst, if I'm going to do a reaction, it may take 1 day or half a day kind of thing. By the use of catalyst, a reaction can be completed within 2 hours or 3 hours depending upon the reaction. Okay. So catalyst is actually, it is it will speed up the rate of the reaction. It will speed up your reaction. It will speed up the reaction. That is the role of the catalyst. How it is speeding up the reaction? By decreasing the activation energy. Got it? So this is all about the effect of catalyst also. Let me summarize. For the reactant to make a product, energy must be greater than activation energy and must collide in proper orientation. And the equation of collision theory is this. Catalyst decreases the activation energy, as a result rate of the reaction increases. As a result rate of the reaction increases. Okay. Is it clear for all of you? Any doubt from this for anyone? So here we are ending up the chemical kinetics lesson. Okay. So initially we have studied rate of molecularity, order, integrated rate law, Arrhenius equation, and at last collision theory. So this is all about chemical kinetics. We will solve one previous year question today and then we will wrap up the today's session. Okay, are you all ready? So this is the question. All of you can take this question and give me the correct answer in the chat box and then we can end up the session. So just try this question, all of you. This is a question from the first topic, from the rate of the reaction topic. All of you try. All of you try this question. For a chemical reaction, rate of formation of C is given and the rate of disappearance of A is given. The rate of reaction and amount of B consumed in interval of 10 seconds respectively will be. What will be the correct answer for this? Has anyone got the answer? Has anyone got the answer? Has anyone got the answer? So by the way, all of you try to do this. All of you try to do this. All of you can take this question as a homework also. In the next class also we can discuss. All right. JNB Gadag is getting option A as the correct answer. Okay. What about others? So Guru, Basavraj and Bhagat is going for option B. Okay. Okay. So I'll give this question as a homework for you. In the next session, I will discuss. Okay. So tomorrow we are having the class now. Tomorrow we will try to. Okay. Okay. Then we Gadag is also going for B. Okay. So tomorrow we will solve this question in the class. Okay. We will try to solve some questions in the next class, and later on we can start up with the new lesson. Okay. So today I am not launching the poll. I have some issues. So all of you can go and study. Thank you so much for attending the lecture. Take care. Bye bye. See you in the next class. Okay. Thank you. Thank you, all of you. Try to join on time like today. Okay.